Hello and welcome back to the second video on limits. So in the first video, we talked about approaching some number, right? The example that we used was infinity because we know infinity is not a number. It's just a place we cannot get to. So we can only approach it. And to approach things in mathematics, we have to use this tool called limits. Okay? So what I want you to imagine is maybe this is you. Okay, and there's a place you want to get to, for example, infinity that you know you cannot get to, right? How do you actually get there? Is you use this thing called limits, right? Limits will sort of bring you there to this place or close enough for you to see what's happening at this place. Okay, so I come up with the analogy in real life, what that is like. Okay, so now that we're in a pandemic, we are stuck in Singapore, right? We can't travel out of Singapore. So imagine this is you in Singapore and there's a place, maybe in Italy, you really want to go to, you want to see it, right? How can you go to Italy without actually going there, right? So what you can do is you can make use of this tool called Google Maps, right? In Google Maps, they actually have this guy that allows you to look at the view from the street. So you look at the bottom right corner, there's an orange dude, you grab him and you drag him over here, say the Pantheon, yeah? Drop in here, and there you go. This is the Pantheon that you always wanted to see, but you could not see because of COVID-19. Yes, I'm just going to give ourselves a double click to move a bit further away, and there you are, right? The magnificent Pantheon right from the comfort of your own home. Okay, so I am not in Italy right now, I'm in Singapore, but I can see what's happening in Italy, sort of, yeah? And that is the same as limits, right? You're here, you want to get to infinity, you can't get there, but I can show you what it looks like somewhere near infinity. That is the idea of limits. Okay? So now that we understand what limits are for, let's learn how to write them. Let's learn how to read them. Okay? To write limits, you can think of limits as like a square root operator or a plus sign or minus sign. You write it in front. Okay? So you write LIM, that's the short form for limits. And remember to leave a small space at the bottom to write down these things over here. Over here, I wrote H arrow infinity. That means I'm going to let H approach infinity, right? Because I cannot get there, I can only approach. So that is LIM and then the space below. Okay. And then on the right, you write down the expression or the function, whatever you're dealing with that you need to approach. Yeah. And then this is how we write it. Next, how do we read it? To read this, read it as taking the limit of whatever expression or function you have. In this case, it is f of h as h approaches infinity. So one more time, taking the limit of f of h as h approaches infinity. Okay, so now that we are done with the notation and language of limits, let's look at one specific example of how to take limits. In the next slide, what we have here is an expression. You can see it's a fraction. It is 2h plus h squared divided by h. Okay, and we're going to take the limit of this expression as h approaches 0. So I know the first question to ask is, why are we approaching 0, right? 0 is a number we know how to get to, right? Okay, let's take a look, okay? So this smiley face over here suggests that, hey, this is easy. Let's just substitute h equals 0. And when we substitute h equals 0, you'll see, right? The numerator becomes 0. The denominator becomes 0. And what you have is 0 divided by 0, which is a big no.
No, God! No, God, please, no! 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 No!
Please don't do it. Right? Okay, so since we cannot divide by 0, that is why we have to approach h equals to 0. Right? Because when h becomes 0, this whole thing just does not work. Okay? So let me teach you how to do this, right? Because to actually evaluate limits is quite a complicated thing. But I have just the thing for you. At the Sec4 level, you just need to know this trick, how to deal with limits. You just need to imagine h to be a very, very small number. Yes, remember when h approaches 0, it gets smaller and smaller and smaller and smaller. Yes? So you just need to imagine h to be a very, very, very small number, like this. Okay? And if it's very small, it's not 0, then I can divide. Yes? As long as it's not 0, it's a proper number, I can divide it throughout. Okay, and that's what I'm going to do. Dividing by h to the numerator and denominator. Okay, maybe the denominator first. When I divide it by h, this becomes 1. I divide the numerator, this goes away, this also goes away. So what I have left is just 2 plus h. And in my next line, okay, I still have to write the LIM because I've not taken limits yet, right? LIM of this expression, 2 plus h. Okay, and it is at this point of time you think to yourself, wait, if h is a number that's just very, very, very small, then it's pretty much the same as 2. It's pretty much the same as 2. So after that, you can drop the LM sign, right? This is where we use the limits. We say that, the limits of this thing is pretty much 2. Yeah, so we applied limits to that and we get 2. Okay, but do remember that, hey, the answer actually is not 2, it just approaches 2. Okay, it only approaches 2 or is equals to 2, the equal sign over here, it only is equals to 2 after we have taken limits. Okay, after we have taken limits. After we have used Google Street View to take a look at the answer and then we come back, oh, yeah, it's roughly around 2. That's what we're saying. Okay, so I've come to the end of this video. In the next video, I will actually do a quick one to show the proper ways to evaluate limits, which you do not need to know at a Sec 4 level, but it will be very, very useful because sooner or later in JC, in university, you're going to use it anyway. And it's not something that's really, really mind-blowingly difficult. So if you have the time, do check it out. And until then, catch you on the flip flop.